Thank you, everyone. Welcome to the last talk in this room in fact, welcome to the last talk that this room will exist for, because shortly this room will become part of the big room. Our last talk in here is Louis de Sousa, who will be speaking, not what he'll be speaking about, he'll tell you about it. I'm going to tell you about Louis. Louis is an experienced data and analytics consultant based in Joburg who is passionate about data-driven technologies. He has 17 years of consulting experience in which he specializes in designing and building tailored data solutions on premises and in the cloud. He also does, he's consulted across various industries, and there's a long list on the website if you want to look into the various things that Louis has done. Beyond his consulting work, he's an active contributor to the local data community. He leads the Johannesburg R user group, but we'll try not to hold that against him at a Python conference. And he also leads PyData Johannesburg, which is far better. Perfect. Cool.
Yeah.
Where he shares his expertise and he fosters engagement with other data professionals. I think that's everything we need to know about Louis. Louis?
That's it.
Perfect.
Cool.
Thank you.
Thank you. Thanks, guys. I am here today to speak to you about ducks, right? So, firstly, quickly, who I am. Just thanks for the intro. I run the Johannesburg PyData and R user groups. You can hold it against me, but for running the R user group. So yeah, just shameless plug. We're based in Joburg, so if anyone here is from Joburg, visiting Joburg, great. Guess what? We meet every second Tuesday of the month, and we're always looking for people who want to share their PyData experience and/or R, if you're that way inclined. And shameless plug, you can go to those websites. We essentially host monthly meetups. Okay, so just a quick high level what I'm going to go through. So I'm going to do a bit of an intro. Exactly why does this DuckDB thing exist? Show you some cool features. Give you some examples, and we can do a bit of Q&A. Okay. Now, introduction. So firstly, I noticed this. It was like last year, where my LinkedIn and my Twitter, my X or my Mastodon, they were all blowing up with this DuckDB thing, and I was like, DuckDB this, DuckDB this. All international conferences that I care about were going on about it, and I was like, okay, so it's like so hot right now. Okay, so what? Now, the main purpose of my talk is to get more people excited about DuckDB, right? Okay, because I've been nerding out about it for way too long by myself, and this is my main reason about going on about this. In a few months' time, you guys, after this talk, you guys will all go home and be really excited about DuckDB. You see, you chose the right talk, right? Because, okay, so what's the problem that DuckDB sort of addresses, right? So firstly, there was a quote. 640K ought to be enough, right? Where it was famously incorrectly attributed to Bill Gates. We said, limited amount of memory. Well, actually, sorry. It actually started with an R quote, unfortunately. So the creators of DuckDB were inspired by Hadley Wickham. So he's quite a large personality within the R ecosystem, and he created things like ggplot and tidyverse, and essentially his sort of main philosophy was that if data can fit into memory, then there's no advantage of sending it to a database. Okay, so very much like keep it in memory, shape it, and get out the analysis, right? So the creators of DuckDB started with that sort of hypothesis in mind. But then all of a sudden, when they took a CSV file and they copied it across a network, so that was fairly quick. However, importing the data, processing it inside a database, and then getting it back out, they noticed, okay, there's a lot more. And essentially, these were computer science researchers looking at the fundamental problems within the database space, saying, okay, well, databases are slow without us sort of like indexing content delivery networks. Like these are complex problems, right? So let me quickly show you what this allows us to do. So by us kind of moving to a DuckDB, let me show you what we can do. My first example And this is just to just to illustrate what's going on. So here we have the good old-fashioned New York taxi cab data set that I'm pretty sure everyone's familiar with. This essentially is 1 million rows of data in this demo, and I'm able to sort of interactively play with 1 million rows of data, right? So all of a sudden, okay, I've got 1 million rows of data, and I can play around with it. Okay, that's interesting. Sort of the second sort of example I have is an astronomy one. I do not know the data set, but what I do know is there's 5 million records in this data set, right? And this is using DuckDB, where I can now sort of interact with a 5 million records, and I can now start visualizing it. Okay, so let me continue. So just to show you lots of data, and all of a sudden I'm like, I showed you in a browser, right? And there's no backend, right? That's literally running all in my browser. So, okay, so what's going on here? This is interesting. So DuckDB is a in-process OLAP SQL database, okay? So for everyone, like sort of more developers, a SQLite for analytics. For people who are not, I guess, not as savvy with, or not, I guess, not from a database world, essentially, it's SQLite is quite a popular in-process database that we use. It's relational database, and this is essentially the OLAP version, or the columnar based, and I'll explain shortly what does that actually mean. So normally we have row level data, so think of a transactional data. So that's normally what we call OLTP, and then OLAP is more from a data warehousing point of view, where we care about the columns. So average sales, so we care about sort of things that we can count and average and apply functions to. And so as I mentioned earlier, where I guess the conference scenes and so it is, firstly, it's an open source project. And it is on GitHub, so you can obviously openly contribute to it. And at the moment, so this isn't a small project, so about 260,000 people downloaded it yesterday. There've been spikes of up to like 400,000, so it's a well used database globally. Now, what makes DuckDB interesting is, so it's in process, meaning so it doesn't have the overhead of a server. I'm essentially using it within the process, so within Python, within my browser. And what's great about this is it has a whole lot of client libraries, and it can run across a large variety of languages. Now, the power of it is actually the fact that it is in process and it's quite small. The demo that I showed you, this is essentially an in-process version of DuckDB. So DuckDB is running within my browser via WASM. And I now, based on sort of the ecosystem, you can actually ingest the data and filter it, and then pass it to whatever framework that you want to. Just from a high-level point of view, if you're using this within Python or just for your project, it uses normal standard SQL syntax. So what that means is we can now be sort of compatible with the language that data engineers use, and we can actually start sort of crafting everything. As opposed to having multiple parts of our solution, we can put everything together within DuckDB. So in this case, you would just import the DuckDB library, and you can just run a normal select statement against that database. Essentially, it follows very similar to a Postgres sort of database with lots of cool extra features. So think of it as that way. What's really powerful about this is the query is not run straight away. As it says there, it essentially it creates a relation, which is a symbolic representation. So only when you want to view the actual data is the actual query run. It's not run before that. So you're able to sort of be additive with your query. This is the So what's great about that, because it's additive, I can now actually take my DuckDB query, run my query, and then I can sort of make changes to it, be additive, and then only when I go .show, the queries run. So from a Pandas perspective, we would just, start Pandas, import DuckDB, and we can then just cast them. At the moment, it's only read-only, so you're able to essentially pull all the data from the DuckDB and put it inside a Pandas data frame. Same thing for Polars and the same thing for PyArrow. So it's fairly easy to get them inside there. Now, so why do you want to use DuckDB, right? Because you can do this in Python already. The functionality is there. However, sort of the very much the ecosystem of the extensions is what makes this work quite nicely. So by default, DuckDB has a whole lot of built-in extensions that make life a whole lot easier. So I can now import Excel files, import JSON files, import Parquet files with one line. And for me, that's powerful, because now I can now use a normal syntax and SQL syntax and import my JSON, and I can do a little bit of shredding. So especially when I do something ad hoc, as opposed to writing lots of code, or you can actually just sort of reduce also the complexity and the amount of things you need to keep in your head. There are core extensions, then there are a bunch of extensions that you can actually load at runtime, and this sort of increases the data set even more. And there's even a list of community extensions. So now the community have created even more extensions saying that we can now, we can import a whole lot more data sets quickly into this in-process OLAP database. What's great about this is, so from a community point of view, H3, so if you're into sort of geospatial, Uber formats, literally, it's a short sort of select statement, and I can just say read Parquet file, and I'm able to quickly get the data in and start manipulating it, where previously I would have taken quite a bit of code to actually get things going. A quick sort of primer on Parquet files. From a data point of view, we nerd out about it and we spend lots of time with Parquet files, but I think a lot of people maybe just don't understand, and I think it'll help you put DuckDB into more context, what it's really good at, what type of problems. So in general, let's say even from a SQLite point of view, and even from a relational database, we care about rows. So we have row-based storage, and when we start querying the database, we would then get all the rows based on an index. Depending on what database engine it is, we care about rows. The thing is, even if I want to get product and country, I still need to scan all those rows, even if I have a highly optimized database engine. Columnar-based storage takes essentially the data and puts it in columns. So meaning, if I would like to ask what is the average sales, or what is the average amount for this column, and the amount is in a different column, it can calculate it a lot easier because it's storing it in the columns, and I don't need to pull every single row. I can actually pull the data by column. Now, what's interesting about that is Parquet is columnar-based, and it groups them as well. So it creates columnar groups. So that's quite powerful. So I can say, what was the average sale per year or per month over my data set? And it can actually use the groups to actually pull the data. It will use the groups and the columns to pull the data more efficiently. And that's kind of what the paradigm of OLAP is. So it allows us to aggregate data quite fast. Okay, that's it. Now, within Python, maybe a little bit more of a real world example. I have a Parquet file that is in the cloud, and I load the extension within DuckDB to quickly go fetch the Parquet file, and I would just go read Parquet, and I specify the URL, and it's inside my data frame, and we're good to go. I've literally brought the data in, and I can stop manipulating it. Whereas previously in an ETL world, I would have had to create an ETL, would have to define the schema, and then there was a problem with the schema, and then it's painful. And where in this case, I can now quickly get going without a lot of the overhead. So this is a XKCD a cartoon making light heart of the tar commands parameters that you would have to pass just to extract data out of it. And whereas, for example, recently this week, 1 or 3 weeks ago, they now have a tar example where you can literally pull data out of a tar compression and extracts the data and puts it into DuckDB without all this. I think it's minus XF. Jeez, I don't even remember. Like, yeah, there's a few letters. XFZ. Yeah, exactly. You know. And what's great is that it's like constantly evolving. So at the moment, Delta Lake. So people are more on the data engineering side. You can now import Delta Lake as well. So now, previously, where we used to spin up this whole entire cluster, and you're running Spark, and you're doing all these things. Now all of a sudden, this is an little in-process OLAP database. You've like now imported, your Delta Lake. You can do data warehousing things just from the small little in-process engine. I have to show you now. I have to go show you DB Beaver. So here is good old-fashioned DB Beaver. It's an open source database client. It's probably the best way of mentioning it. A lot of people have used it. So how do I make this practical? If I just right-click on a project and go create new, I lie. New connection. Create a new connection. And in my case, DuckDB is right there, right? We go, DuckDB, and I just go, I want to give it a new path. I'm going to call it DuckDB2 because why not? And then I open that up and I create. What's great about this is now I have a database that's new SQL query. Think of it as it uses a Postgres, so normal, like a traditional database schema. So this is the database that people like know and love, that most SQL people would be like, oh great, this is a database with views and everything. What's great about this now is, let me change this to DB2. Great. And let me zoom in here. No zooming. Well, no, there is zooming here somewhere. But okay, you guys are going to have to believe me that I'm able to use normal SQL to create a table, and I can now sort of browse it as a table, and you have table and you can start using it. Go use DB Beaver. You'll be really it's a nice way of interacting with DuckDB. Okay, so what's a really cool thing? Slightly DuckDB related, but more DB Beaver, which a lot of people should know. This is really great. There's even now OpenAI integration, so I can say stuff like, what is the average price of the products? And it'll take the database. This is a DB thing, and it literally takes the product, the schema, and it sends it to ChatGPT, and it actually writes SQL for you. So we don't even need to learn SQL anymore. But okay, that's besides the point. Try it out; it's very cool. Okay. What made me what kind of sold me on DuckDB even more was the fact that the likes of Fivetrans, so they're a online ETL provider. They're a billion-dollar company. They actually spoke about using DuckDB in their architecture. So they've actually invested in, an angel investor in it, and they have actually used it to export data to Delta Lake. So that, as a main part of their architecture, they've actually integrated DuckDB into their product. So from an enterprise point of view, so there is an open source version of DuckDB, but there's also Mother Duck, which is the sort of enterprise version, which solves a lot of problems that the open source version has. So largely, if you want to run this at an enterprise level, you care more about enterprise features. They have a way of making it sustainable. There's also, for example, like GeoParquet. So we're able now to take Parquet and store geographical data in it, and now we can import it and start visualizing it. There's some really great projects. That's 7 million coordinates. I know that a few years ago, 7 million coordinates would destroy most machines that I owned. But nowadays, it literally we can use so many coordinates without cooking our poor laptops. At the moment, probably for me, so the demo that I showed you earlier with the maps and stuff is essentially using WASMs. So probably the biggest thing is running DuckDB in process within your browser. So you can run normal database queries within your browser, and it's all happening in memory. So what's great about this is if you have an application and now you want to start importing Parquet files or JSON files, and you want to do a little bit of data manipulation at the edge before you send it up, this is an easy way of doing it. There is the book written by the guys from DuckDB. It is freely available on the MotherDuck website, so it's a good place to start. And also their YouTube channel. So they actually run a conference called DuckCon, which they go through a lot of like the newer features and stuff like that. What's so interesting is the creators of DuckDB really like leaned into the whole duck thing. Like he kind of spoke about pitching up on stage in a duck suit, and he was like, that was way more ROI than any sort of marketing. They spent all the money on like some marketing stand, but turns out he was pitch up on stage with a duck costume. So it turned out, turned out quite cool. Do you guys have any questions? Let's touch base quickly. Yes. How much time do I have? Sorry, just to...
Oh, well, we're 10 minutes before lunch, and we would have run a little bit over anyhow because you started late, but cool, thank you.
Happy? That's fine.
I was just going to notice that, naming your product after something to do with a duck doesn't give you many opportunities for absolutely foul puns.
They really sort of leaned into it.
Grab that one before anybody else did. Thank you. Louis, does anybody have any questions? Anything? There we go.
Yeah. I can speak about this for hours, and I think my main purpose is just to make sure like everyone is happy, and I need your guys' feedback. You need to tell me. Yeah.
Okay, a very nice presentation.
Thank you.
I have a very simple question. Is DuckDB more of a relation DB or?
Think of it as you'll get back the data in a relational format. So this is what what I'm showing you here. This is relational, but think of it as the main use case is not a sort of traditional sort of row-based or transactional-based. It is more for columnar data. So it's more for if I want to aggregate lots of data. So if I care about certain columns, that's where the performance in this is. And the fact that there's a lot of so this was essentially people who did database research who we're only running the query at the very last second, and because it happens in memory, it's very quick. So those are the problems that it's.
Yeah. One more question.
Yeah.
In case I have two more tables, am I allowed to pull data between the two tables?
So say that again.
Okay, if I have like two tables in that DB, right?
Yes.
And I need data on both tables in the same time.
That's right. So what you'd normally use, you would use traditional sort of SQL syntax to join the tables together and get back the data sets. So what's interesting about that is you're now able to generate SQL that your data engineers care about. Now you can still interact, even from a data frame point of view, you can still interact with it, manipulate it, and use whatever framework that you're familiar with. And actually, every time you're calling DuckDB, it's actually generating SQL there. And that way, you can almost you use DuckDB almost in a way of giving your data engineers, because then you actually have SQL that you can give them. But you can use whatever underlying framework that you care about.
Good. One last question.
So, yeah.
On the capacity side, how much of data can store on 1 terabyte?
So a lot of this is so the power of DuckDB, it only loads what it needs into memory, right? So the Hadley Wickham quote that I tongue in cheek started the talk with. That kind of speaks to the fact that when we look at data problems only from the amount of memory that we have, right? Then all of a sudden we have cases, I've seen it, where you have a few hundred gigs of memory just to be able to now manipulate data, which isn't it isn't really that practical. But what's great about this is it only loads in memory what it needs at that time. So it's able to process sort of really large data sets. And the fact that it's using Parquet, it can be very smart, where I can literally now pull data from a S3 bucket or a Azure blob storage, and it only fetches the Parquets, but it's built into the HTTP format. It only pulls the Parquet files that it needs, only pulls the columns that it needs, loads that data into memory, and then only processes what it actually needs. So yeah, super performant. Thanks for the question.
Any further questions while I'm up there?
So not so much a question, but more a comment. I think it would be a really good integration to the previous architecture that we just saw with, filtering data for that city project. Yeah, it would be pretty excellent.
So definitely, as soon as I saw that, like shredding JSON or just aggregating data, like really quickly, it's really good at that. That's essentially what it's for. Yeah, that's cool.
One question's come in online, and then I'll take
sure.
yours. A question from Lehan Kutsias is, at what point in terms of DB size should you consider something like ClickHouse instead of DuckDB?
Good
Clearly,
question.
that means something to you. It means nothing to me. Okay.
So ClickHouse is I'll show you now. It's in the beginning. Yeah, I'll show you the picture. There's a picture. It is essentially considered client server. So I think a lot of the times, I'm going to give the consultant answer with it depends, right? And largely it's on your architecture. I think like a lot of this comes down to, time, money, effort, skills that you have, your architecture. I don't think the DuckDB guys' whole philosophy was that client server, I'm sending data over the line. I need to send it away. So I think that's probably the easiest just in the whole decision tree. Like that's probably the first thing you'd think about. Do I need to send the data somewhere else to be processed, or can I process it here? That's probably the first point of call. And what's great about this is, can I process it here? It could mean anywhere. Like in browser, on my app, in my Python app, in my R script. Cool.
Hi, thanks.
No problem.
I actually came across DuckDB doing a DLT tutorial.
Okay. Yes, okay.
And I mean, the way that they showed it was that DLT can now interface like with multiple databases, and DuckDB was kind of like, it's like, go-to first. But my thing is, like you said in the very beginning, is like, okay, using like Parquet files, but I mean, like you just showed the dbeaver now, you can actually spawn up the DB. So can it now write to the DB? Okay, first question. So when I'm saying now can it write to the DB,
Yes.
of course. So using like SQL, all these other things, so you can actually store that data. Are you saying because now you can spin up on dbeaver now an instance essentially of the DuckDB?
Exactly.
And then also within the coding, can you now do multiple queries on different data sets using like the Python
Yes.
library?
Yes, you can now. Okay, what I wanted to show you was, I'm wondering if I could actually zoom in here. My zoom is can't figure out how to zoom in this for some reason. Okay, but man, window. Just give me 3 seconds. Zoom in. Control ++. But yeah, but that's exactly what I did. Control ++. No, guys, come on. Okay, anyway. I'll quickly take you through a demo here. So in my case, so this is within DuckDB. I'm creating a table and I'm inserting some records inside it. This is storing it inside essentially just a DuckDB file. What's great about this is I can now use standard DuckDB SQL or just standard SQL just to do a select star. So just a normal, like a traditional relational database. What's great about this now is It also has windowing functions. So within relational databases, when we want to average over records, I can now do, okay, I want to do the sum, but now I want to order it by a different column. So we can use these funky things. Well, another great thing that you can do now is I can create a table and I can insert JSON data into it. Okay, so insert some JSON, and what's great about that is now I can shred the JSON literally just using like a few modifiers to just modify the JSON files. That's pretty cool. And now I have good old-fashioned group by. I can have sort of aggregate the data, and then I can use time-based. So there's age. So there's like you can use like lag. It's essentially all windowing functions. So all these people who care about what happened with the last record, what happens with the next record. That's essentially what windowing is about. We can use CTEs, so common table expressions, so tables that don't get persisted to the database. And I've done all of that stuff, and now I can just save it to a Parquet file, so I can output it. So now I can output, and essentially the point I wanted to make here was I literally have my traditional SQL syntax. I can output it to CSV, Parquet, anything that someone creates a connector to, and it's essentially one line, and it's quite understandable what it's doing, right? This is writing a products Parquet file, and then to read it, I just say read Parquet. And if I take this file and I copy it to my blob storage, I literally just have to then just put the URL in there, and it will read it as if it was on my local machine. It's a vibe, guys. It's a vibe. It's a vibe. No, this is great. Yeah.
Awesome. So was there a
Yeah.
hand? Okay. Yeah.
Hi, thanks for that. So yeah, just disclaimer, I've got very little like sort of data analytics background, but I find this very interesting. And yeah, so don't shoot me if I'm asking a stupid question here. So what's the difference between this and like alternative sort of ad hoc SQL sort of engines for big data analytics like Presto or Hive?
Ooh. Now, what happened was, let's say 10 years ago, we all went on this big data craze, right? Where we spin up a master node, and then we spin up all the workers, and then all the workers do the job, and then they bring back and it aggregates the data and sends it back to you. And that's essentially been the dominant architecture. So like within large corporates, that's what you're going to sell, and that's what you're going to say. In this case, it's saying, I can look at those same problems. Turns out you don't really, no one really, even locally, we don't have problems that are that large. Yeah. Maybe AWS has, maybe Amazon has, but realistically, most corporates, you could probably spin up one really, really proper node, and you can actually do this all in a very efficient way, but that doesn't pay the bills, right? However, I think we're at a point now where people have looked at that problem and they're like, okay, it's cute. What's great about this is you can also, DuckDB has a Hive extension as well. So you can even connect to a Hive store, pull the data inside DuckDB, and actually do all your modifications in it. So the big data architecture, it works. It really works. However, this case, same problems, but just smaller engine. It goes fast. It's like a Japanese car that's been souped up.
That's like a cost benefit ratio. I
Totally.
guess. Okay, that makes that kind of puts it, because so that's all I ever hear of.
That's
like,
it. It's
Hive and
fast.
Presto, no,
It's fast. It moves really quick, but it's the radio inside the car is a little bit dicey, guys. It's still the old digital.
and would your typical application be sort of inside notebooks and stuff like that?
So at the moment, for example, within the ETL world, I've used it personally to sort of even build smaller data warehouses. So we can use it for essentially acquiring data, transforming it. It's really performant with that stuff. Or actually use it within applications where you want to do stuff at the edge. That's the interesting stuff that at the moment I've seen it being used.
Very cool. Thanks.
No problem.
Thanks, Louis. So basically, one of the things you're saying is it'll also help you save you from a large, big bill. So
Most definitely.
I'm out of duck puns now.
Oh, well done. Well done. Oh, wow. 10 points.
Sorry. If you have to point out it's a pun, it wasn't a very good one, in fairness. But, any further questions for Louis, or are we going to call it? We just hit 3:30. Evan starting late, perfectly on time. Fantastic. Thank you, Louis. Thank you very much.